Welcome back, everyone. In this video, we will go over the final part of Lecture 12, which will just be a summary. In Lecture 12, we learned about the risk-neutral pricing. The main result from risk-neutral pricing is the fundamental theorem of asset pricing, or the FTap. The FTap states that the price of any security is equal to its discounted expected payoff under the risk-neutral measure, or x0, the price of any security, is equal to its discounted e to the negative rt expected payoff under the risk-neutral probability measure. The FTap is a completely general asset pricing result. However, our choice of model will affect its computation, specifically its computation of the expectation term. In the binomial model, the FTap is going to simplify to the following equation. E to the q, EQ, xt is going to be given by this bracketed equation below. It's going to be equal to the probability weighted average payoff of x, qu times xu plus 1 minus qu times xd, where the risk-neutral probabilities, qu and 1 minus qu, are given as follows. A final thing to note also was that risk-neutral probabilities do not equal real-world probabilities. Q does not equal P in terms of the probability measures. Okay? And the reason why is because the risk-neutral probabilities adjust the real-world probabilities for the market price of risk. Risk-neutral probabilities are synthetic or mathematically constructed probabilities that allow us to price assets in no arbitrage settings, while the P probabilities do not allow this unless we make some risk adjustment. Yeah? For most of you, the FTap is going to be a completely new concept, and it's going to be much different than the pricing rules you've learned before in your finance classes, like the NPV rule in your corporate finance classes, which says the price of an asset is equal to its discounted expected payoff under the physical probability measure, with discount factor being the WACC, or the capital asset pricing model, which says that the price of an asset is also its discount expected payoff under the physical probabilities, this time discounted by the CAPM, expected return rate. Okay? For derivatives, the FTap always reigns supreme, okay? And the FTap should always be used instead of the NPV rules and the CAPM. Okay? There are a couple reasons why you should use the FTap instead of these rules. So in general, for pricing derivatives, the corporate finance NPV rule will be wrong, and so will the CAPM. Okay? And one of the main reasons why you should use the FTAPs is that the inputs are observable and the prices by construction will not admit arbitrage. Both the NPV rule and the CAPM will be limited in one of these respects. For the NPV rule, what's going to happen is that you're going to run into an unobservability problem. While all the inputs to the FTAP can be observed in the market, the risk-free rate can be observed, the risk-neutral probabilities are backed out from prices. Okay? The physical probabilities must be forecasted and estimated. Okay? Much more difficult to back out than the risk-neutral probabilities. P probabilities are much harder to obtain than risk-neutral probabilities. Okay? Also, the weighted average cost of capital is not observable while the risk-neutral state prices are. Okay, so if you ask everybody in the class to estimate the WACC of Apple, you're going to get about 100 different answers, okay, which is going to show that this WACC that's used in this computation is not going to allow you to admit no arbitrage prices. Different people are going to say the WACC is different. It's not going to give you a consistent framework. If we use the FTAP instead, everyone in the class is going to come up with the same exact answer. Okay, the CAPM also suffers from very similar problems. It relies on real-world probabilities, which are unobservable, along with the market risk premium and beta, all of which are unobservable, and we'd get a different answer from everyone in class. And the second problem with the CAPM is that it only accommodates one source of risk. So the CAPM is only going to accommodate market risk, While the FTap, although in the binomial model it doesn't, the FTap can be used to accommodate any arbitrarily large numbers of risks. Okay, it's a completely general pricing rule. Okay, so that's it for this lecture. The main takeaways is that we learned about risk-neutral pricing. Main result from risk-neutral pricing was the FTap. Price of a security is equal to its discounted expected payoff under the risk-neutral measure, where the discounting is done by the observable risk-free rate. All the inputs to the FTap are observable, okay, and it's a strictly superior pricing rule for pricing derivatives relative to the corporate finance NPV or the CAPM equations. Okay, so I'll see you guys in the next video.